Hi class, today we are learning 1.4 prime factorization, and the walkaway for today is I can write the prime factorization of any number. First of all, it's important that we understand certain key words, certain key vocabulary that we will see throughout this section. Prime number. A prime number is a whole number greater than 1 with exactly 2 factors. And those 2 factors are 1 and itself. In other words, there are no more factors for a prime factor except for 1 and itself. Okay, and then the definition of a composite number is a whole number greater than 1 with factors other than 1 and itself. So composite numbers have more. They're also greater than 1. And they have other factors more than just 1 and itself. Okay, definition of a factor pair. Set of 2 numbers which when multiplied together result in a definite number. In other words, 6 and 4 are a factor pair. It is a factor pair of 24. Why? Because 6 times 4 equals 24. I'll write that down. 6 times 4 equals 24. So the factor pair of 24, or a factor pair, is 6 and 4. Prime factorization. Definition of this is a number written as a product of its prime factors, and we're going to get to that later on down here. And a factor tree is a tool that breaks down any number into its prime factors, and once again we'll do that here. So the key for finding the steps for doing prime factorization is 1. Find a factor pair and draw branches. 2. Circle the prime factors as you find them. And 3. Find factors until each branch ends at a prime factor. And we'll better understand this as we do it. So let's go ahead and try one. So first of all, together let's do this one. If we start with the number 48, we come up with any factor pair that we know that equals 48. So I chose 2 and 24. 2 is a prime factor, so I circle it. And the reason why it's prime is because its only factors are 1 and itself. 24 can still be factored more, so I keep going with 24. I think of 2 times 12. Once again, I circle 2. 2 is prime because there are no other factors besides 2 and itself, but 12 can still be factored. So I think of 2 numbers when I multiply them together that become a 12. What about 2 and 6? 2 is prime, 6 is not, so I keep factoring 6. What 2 numbers or 2 factors can I multiply to get 6? I think of 2 times 3. 2 is prime, 3 is prime. So this is a factor tree. What we made right here is a factor tree. And like it said right here, we find all the factors until each branch ends at a prime factor. So when I have circles at the end of each branch, I know they're all prime. That means I'm done. So this tells me from this factor tree that 48 is the same as 2 times 2 times 2 times 2 times 3. Another way to write that, which we learned in our last section, is 2 to the 4th power, because there's 4 of them, and then times 3. And this is the prime factorization of 48. So if you ever asked on a test or a homework assignment, what's the prime factorization of a certain number? The final answer would be 2 to the 4th times 3 for 48. Let's try doing 16, the prime factorization of 16. So I ask myself, what are 2 numbers that when you multiply them together equal 16? Any 2 that we can think of. You might say 4 times 4. I will circle neither one of these because neither of them are prime. They have more factors than just 1 in themselves. So what can you think of? What 2 factors when you multiply them together equal 4? Yeah, 2 times 2. Both of those are prime because there's nothing more than 1 in itself that we can factor them to, so I circle them. This one was also 4, so it's 2 times 2. Once again, I circle them because they're both prime. So 16 is the same as 2 times 2 times 2 times 2. That's what we discovered right here. And a better way to write that is as an exponent, 2 to the 4th power. So if someone asks what is the prime factorization for 16, the final answer is 2 to the 4th power. See if you, go ahead and pause and try and see if you can figure out the prime factorization of 54 and then the prime factorization of 90. When you're done with those two, please bring them to me and I'll see if you understand how to do prime factorization.